today we're going to kind of review what we learned in last week in lessons 8.1 and 8.2 about vectors. So our objective for today is to guarantee that we are all capable of measuring a vector to get the magnitude and direction with our protractor. We also want to make sure that I can give you a magnitude and direction and you can draw that vector. And then we're going to be able to combine vectors and find the resultant algebraically and geometrically using tip to tail. So we're going to briefly review a few of those skills, and then I'm going to let you work with your shoulder partner on an activity where you're finding Captain Vector's treasure. Y'all like that name? I came up with it. Okay, anyway. So the first thing I want is for you to look at number 1 on the screen for me and see if you can answer that. It asks you to find vector A plus vector B using what? The tip to tail method. Alright, so do y'all want to try it and then discuss it, or do you think you need someone to refresh your memory on how to do tip to tail?
Try it.
Try it first?
Yeah.
Okay, alright, so we're going to take like a minute or two and see what you can come up with. According to my random student picker, Ben Butcher is up to share an answer, so Ben says that the resultant is 4.1 centimeters in magnitude and has a direction of 22 degrees. Do you agree with him? Do we have to be exactly the same as him?
No.
No. I told you what the rule is. How far can you be off?
3, 2, 3.
If you're only doing 1, then it needs to be about 0.2 or 2 degrees, right? If we're doing multiple vectors, then I gave you a little more leeway. Why did I give you that leeway?
It's human error.
I have a question before we move on. Yes, sir.
Okay, so I don't really remember how to do it. How do you find the magnitude and direction?
Magnitude and direction is basically the length and the angle. So once you draw the resultant, you use your protractor to measure the angle that it makes with the horizontal and then how long it
Is
is.
it really what it is?
Emily Simmons, can you explain to us why we use r cosine theta, r sine theta? R sine theta came from? You want to put it on the board? No? Thank you. I think this is probably on. Okay. Alright, so we labeled our triangle like that. Are y'all okay with that?
Yes.
Everybody knows where those came from?
Yes.
R was our vector, and we said this would be the horizontal component, and that would be the vertical. So where does cosine and sine come into play? Has to do with... Ooh, keep talking louder there. Okay, so if I'm in reference to this angle, I have an opposite over, this is the one thing that I know at this point, right? I know that and I know that. When I know things about my vector, I know a magnitude and a direction. So I know the length of this side and I know the angle that I'm dealing with, right? So to find these components, my vertical and horizontal component, I can set up that if I'm looking for this guy, and I know this one, so if I'm looking for the vertical, but I know the hypotenuse, then I have opposite over hypotenuse, which is what? Sine. So we know that sine of the angle is equal to the vertical over the hypotenuse. So if I'm trying to find y, I can multiply by r. Right? And then we made a similar argument for finding the horizontal, because at that point we know adjacent and hypotenuse, which gives us what? Cosine. So that's my r cosine theta, following the same argument. So your first job, number 1, is asking you to pick an X on that paper and write it down so you remember where it's at. Okay. Number 2 wants you to decide where you would like to have your treasure buried. So pick another spot.
We do one thing, we gotta do it.
Another X. Yes, on that paper. Absolutely. All right. The other thing you're going to do is you have to create at least, well, only, let's go with only for time's sake, 4 vectors that connect you from your start to your finish. You do not, are y'all listening? You do not have to connect with any other X's along the way. Connect your start to your finish however you want to using 4 vectors. All right, the rest of it, I think if you read the directions, you're going to be able to follow along. If you have questions, you're welcome to ask me. I'll walk around to help you as you're working. All right, I would like for us to take no more than about 10 to 15 minutes to get those vectors drawn and to get your directions written down. Okay? All right, so according to this clock, it's 10:18. 10:19 now, sorry. All right, so we'll say about 10:30 to 10:35 is when I'm going to stop you, and you're going to have to switch. Got it?
So I need to start Z. I need to put the X, E right here.
Yes. Identify a place where you want to bury the treasure. Check. Your treasure should be buried at one of the X's. Identify it by letter A, B, C. Do not write on the card or tell your friends until they locate treasure. Create a course using vectors from your starting point, which is XC, to your treasure. You must use 4 vectors, so only 4. Okay, well, we can't do it. Each vector should be labeled with the magnitude and direction of the map. Vectors do not have to end on an X. Write each vector on a separate note card in the form of walking instructions.
So we gotta write what we do every time we do it?
Yes. Yes, but we needed a starting point for it to go to. And then you're like, oh, wait, you're doing it. So we can do it.
Right, and then I'm burying it.
Second west. For how long is that? 7?
So 7.
Is this going to be south and west?
That's west. No, that's. Is it south or is it east?
It's going southeast, southeast.
East.
Swest. Going swest. We should write that. Swest and swest.
Yes, west and east. Confuse them even more.
Swest and ceased. Ceased.
I mean, I understand like walk west, but then it gets
So, is this a pencil? Yes, ma'am. You're starting where?
This one.
Here?
Here.
Here? Okay, so I would say send them around the world and back again. Here's my first sector. Here's my next one. Here's my
Oh, so basically we're just
There's
measuring
my next
lines
And then, yeah, you're going to measure this vector from the horizontal and tell me to walk, say, if this is 30, you would say go head 30 degrees north of east for 5 feet and a foot and a centimeter.
So every point we measure a straight line.
Like we do
We do a horizontal, so I'll do horizontal.
You'll do horizontal from every spot where they meet to measure the next guy.
Okay.
9 degrees is like over in a place. 9 degrees is going to be kind of like,
Yeah.
can't really mark.
That's the only thing in that area.
Right.
That's not going to be 90%.
Right.
So it's going to be K.
It's gonna be K. Is that where we're gonna land?
Yeah.
Okay. We gotta do the magnitude. And like we have to draw the
So
okay, 1, 2, 3, 4. Yeah. So then we're just gonna draw
from A to K.
Yeah, from A to K. Yeah.
9.2.
So y'all go ahead and shuffle your cards. Alright, you need your starting note card that tells them where to start on top. The rest of them you can mix up. Okay? And then switch. Alright, once everybody gets this, then we'll have a small conversation about what you're going to do. Alright? Now, you have 2 papers that I just passed out, right? You have a fresh map, and you have like a worksheet. On your clean map, identify where they told you to start, and then from there, you're going to follow the directions on the cards in the order that you have them. Make sure you pay attention on the worksheet that I want you to write down the vectors that you were given, the directions. Fill in the worksheet as you're going. Alright, again, you have your shoulder partner there so that you have someone to discuss things with and make sure that we're doing things properly. Make sure both of you are involved in the process.
I'm confused.
If you followed their directions and you didn't find the treasure, like you may have, but if you didn't find it,
If you didn't, you
may have been really close, but you dug at that exact spot and
Someone
didn't
could
find
have
the
wrote it
treasure. Their directions could have been wrong.
Okay.
You could have done what?
done it like measured wrong.
Measured incorrectly. Yeah.
Okay. Oh, okay.
So human error.
This is going to come from you measuring what you got when you did tip to tail. This is going to come from you doing this math. This is the horizontal and vertical component of R cosine theta, R sin theta, to find these guys.
So we just like
Using their directions, yeah. Using like, this is R and that's theta.
Today we reinforced the skills that we had already learned, being able to get magnitude and direction of vectors, being able to add them algebraically using component form, and geometrically using tip to tail. And we have discovered that it doesn't matter what order we do them in, right?
True.
If I can combine vectors in either order based on the commutative property, correct?
Yes.
Alright, so who can tell me why you think that some of us were not able to find the treasure by using our protractor and the tip to tail method? Hunter.
People are good at giving directions.
Some people aren't as good as others at giving directions as far as making sure they get north of east and south of west and those kinds of things, correct? What else?
Human error.
The human error involved. If you were only a little off, if you got close to the X you were supposed to, but you didn't get there exactly, that's going to have something to do with the person that did the measurements in the first place and gave them to you, and then your own error in measurement. If you were way off and you ended up in the water, that probably has something to do with, we might need to have a conversation tomorrow of exactly what south of west and north of east and those kinds of things.